So the first question will be to introduce yourself.
Yeah, my name is Pragyan, and I have passed in mechanical engineering from Jaipur Engineering College and Research Center, Jaipur. And currently, I am a production supervisor at SBNPL, and we are Asia's number one technology giant in the field of stone cutting and polishing machines. Recently, we have also developed 44 model, that is 44 blades cutting machine that is made first time in the world, and we have patented it also.
Okay, let me just write the feedback for this question. Okay. So next is any final year project?
Yeah, my final year project was augmented reality headset.
Oh,
It's a little unconventional for a mechanical, but yes, I took up the challenge.
okay. And that was mainly done by you only, like the coding part, everything, or you had a team of computer science people
No,
also?
I built the AR headset, which was using light optics, not any electronics or any coding, so
Okay.
as to make it more power independent and cheaper.
Okay. So then next question which comes out is, why do you want to join merchant navy?
Uh, I want to join machinery because I think the superpowers in history and superpowers in the present are made due to their power in the seas. And my aim is to become the best mechanical engineer, marine engineer, so as to help my nation become one.
Okay. Feedback for this. Okay, so next is going to be which company you're going for? Great Eastern, right?
Yeah.
So why should Great Eastern hire you?
I think, sir, one of my greatest positives are that even though I'm a slow learner, I am ready to accept any harsh reality, or am ready to take any challenge which rather seems impossible. It might take some time to crack it, but I will crack it, and I have that capacity. I have the persistence.
Okay, so is this the only thing that you're banking on, or do you have something else as well?
Uh,
So some other skills
I
that
will
you.
prepare this answer.
Okay, so I'll write the feedback for this. Okay, so next thing is, what are your biggest strengths and weaknesses?
So my biggest strengths are that I'm flexible enough, both flexible and rigid enough in my character. Like if today I see something that is good for my life or my health, I, I will change it immediately without even thinking twice. And second, sir, that I have vast knowledge about subject area. Mm. I have to prepare this question, right? My strengths and why we should select it. I
Okay.
had thought of the answer, but I'm not remembering.
Hmm. Okay, so we'll just put it on as left to be discussed later. So tell me the main parts of the two-stroke diesel engine.
Yeah. Uh, the main parts of the two-stroke diesel engine is as follows. First is the crankcase. Second is the inlet and outlet port, the transfer port, piston, crank, flywheel, governor, and piston rings, uh, gudgeon pin, and crank pin. That's all.
Okay. Okay, feedback for that is done. So now tell me that you mentioned that there'll be multiple valves and ports that are there. So these will be opened up by valves. So how do these valves open and close?
These valves open and close with the help of a pump pipe. I'm missing out on this either pump or a motor. These valves open and close with the movement of piston in some types of engines. And in some other, we also use uh, motors, electric motors.
No, no, this has nothing to do. This is based on the rocker arm camshaft. I'm talking about the inlet and outlet valves on top.
In two stroke.
In two stroke, you'll have your this thing, exhaust valve. So that will be opened up by the this thing, rocker arm to in general, like any two stroke or four stroke, wherever you have your valves on the top, the rocker arm will be pushing them down whenever the camshaft uh, pushes the push rod higher up.
Yeah, that is the same in two stroke also, right?
Yeah, but you're saying mainly on motor, and also that would not come in that.
Sure, I will know it.
Let me just make note of that. Okay, so now that we come to this, explain the full rocker arm assembly.
Yeah, sure. Should I explain or should I go also down?
If you can draw it for me, okay, draw it and then send me the image on WhatsApp. I'll verify that as well. So draw first, and then later you can explain whatever you have drawn and the working of that.
I'm really sorry, Avito, but I have not practiced the drawing yet. I will practice first, but let me explain.
Yeah,
I was
draw it
just
whatever.
going to draw it in the.
Whatever is possible will be okay.
Okay. Yeah. I made a rather simple diagram. I know that it's
Okay.
elaborate. I will work. Here is a can.
Hmm.
When the can will push the tappet, uh, the the rotational motion of the can will be transferred in form of linear motion to the rocker arm. When this rocker arm at the rocker arm at the top will push or either be relaxed, uh, thus making the valve cams operate
Okay.
by the pressing mechanism. When the rocker arm will press on the uh, valve cam, the valve will open. When
Okay.
it will not, it will be closed.
Okay. Fine. So next thing, since you're again with the drawing only, draw for me the valve timing diagram of a four-stroke petrol engine. So valve timing diagram of four-stroke petrol engine.
Should I also mention the degrees?
Yeah, I mentioned the degree, everything.
I have revised it here,
Okay.
but let me show you that, what I remember from the
Hmm.
earlier study.
Okay.
In this diagram, this is TDC and DDC.
Okay.
Okay.
Just take the phone slightly further back because it's getting blurred. Yeah. I think now it's
Now
okay.
it's okay. The intake valve opens 10 to 20 degree before TDC here
Okay.
and goes up until 30 to 40 degree after BDC.
Okay.
Then the spark ignition is then with 20 to 30 degree before TDC and carries on until 10 to 15 degree after TDC.
Okay.
Now the exhaust valve opens at 30 to 50 degree after TDC and closes at 10 to 15 degree, 10 to 20 degree after TDC.
Okay. So
Now,
yeah.
point which I was missing is that I was not remembering when the compression got over in that.
Okay. No issues. So the question now is, as I see in your diagram, you have said that at some points of time, your inlet and exhaust valve will both be open.
Yeah.
So why do we have this valve overlap taking place?
Actually, a healthy amount of valve overlap time is good for the engine because it will help us scavenge in scavenging better.
Okay.
That's
Okay.
the reason.
I'll write the feedback. Okay, so then we move to the next question, which is now I need you to explain for me what is the lubrication system between two stroke and four stroke. First, give me a general idea of what you understand by lubrication system, then how it is done in two stroke and four stroke. Mainly, don't forget to specify based on total base number.
Uh, a lubrication system is a system in which it could is a system which supplies the lubrication oil to different parts of the engine, like the crankshaft, mainly the rotating parts, which can create heat or friction, like the crankshaft or the cam heads or the camshaft and the crank mainly. And the difference in systems of four-stroke and two-stroke uh, is that in four-stroke we have a centralized lubrication system, and in two-stroke we have very mixed lubrication system. Either missed or either with the help of the crankshaft. In the crankcase we have the lubrication.
Okay.
In two-stroke the lubrication is mainly in the crankshaft. In the crankshaft we have the lubrication system is sometimes mixes with the fuel when it is transferred to the transfer.
Okay. What about TBN?
I don't know.
Okay. So in two stroke, can you tell me why we have the crosshead bearing?
I don't know.
Okay. I'll make note of all of that. Okay, so tell me the classification of pumps.
The classification of pumps is as follows. Mainly, it is under the dynamic and positive displacement. Then, under the dynamic, we have centrifugal pumps, which are sub-classified into axial, radial, and mixed. Then, in the positive displacement, we have rotary. The other one is reciprocating. And in rotary, it is subdivided into rotary vane or rotary vane pump or gear pump or screw type pump. And in reciprocating, we have piston displacement and the diaphragm pump.
Okay, so diaphragm, can you give me an example?
Of diaphragm pump,
Yeah.
no, I don't know.
Okay. So, can you tell me the difference in the efficiency between rotodynamic and positive displacement when we're talking about the discharge of the pump? So, based on the discharge of the pump, what can you tell me? How will efficiency change in rotodynamic and in positive displacement?
That too,
Okay. So, we made note of that. Can you draw the centrifugal pump
yeah.
and label all the parts?
In order to display the inlet and outlet side, I've made it here. Otherwise, it would be like this,
Okay.
visible inside.
Okay.
Now, should I explain it?
Yeah, tell me the working of the whole thing.
Yeah. In case of rotodynamic pumps, in this case, this is a centrifugal pump. These pumps are mainly used for low pressure ranges but high volume transportations. And the working is as follows. The fluid enters from the inlet suction side or the inlet side, whatever we could call it, and it is sucked in due to the vacuum created by the rotating impeller eye. When the impeller eye rotates, the impeller is mounted on a common shaft with an electric motor. So, due to the rotation of the motor, the impeller blades also rotate, which uh, which sends the fluid radially outwards into the volume casing with a high kinetic energy. And due to the differential shape of the centrifugal pump, the this differential shape of the volume casing, the fluid's kinetic energy is converted into pressure energy, as according to the Bernoulli's theorem. And this high pressure fluid is sent out through the discharge side.
Okay. So, within the centrifugal pump, there's also something called as a sealing box. Can you explain what the sealing box is? Where is it
Yeah,
located?
yeah, the sealing box is on the common shaft that we talked about, and it is used to seal the fluid inside only, inside the pump. so that there is no leakage outside the pump on the shaft or in the surroundings. And there are two types of sealing. The first type is mechanical sealing and other is gland plug sealing. Uh,
Okay.
should I explain that also?
Yeah, so tell what is the how is it made and all of that.
Yeah, mechanical seals is mechanical seal is just like a gasket, and
Yeah, mechanical
in
seal is
gland
not used in this
packing,
case, but which one is used in this case, that's the one you have to specify. In centrifugal pump, which one is used?
it can be it is based upon the application of use. Like if there are any slurry materials or waste, we can use blend packing because if there is any leakage, it will not be a big deal. But if there are any inflammable substances or toxic substances or fluid which is harmful to human beings, then it should have a mechanical seal.
Okay.
The gland sealing is made up of braided ropes around the shaft. It is put around the shaft and tied around it. The major difference in mechanical and gland seals are that gland seals are cheap and are easy to install because we only have to tie it around the shaft. But in mechanical seals, they are expensive due to their installation operation because we have to for the insertion of the metal grip on the shaft, we have to first cut the shaft and then insert the mechanical grip on it.
Okay.
But I think we can also resolve that thing by using different types of coupling in the shaft.
Okay.
Like if we use the muff coupling method, it will be very easy to install and operate the mechanical seal.
Okay. What's the material of the gland packing?
Material is
Made out of what?
braided, ropes are braided.
Yeah. Okay, you're saying braided rope, but made out of what? Normal cotton, you're saying?
Synthetic fiber.
Okay, synthetic fine. Fine. So next thing, tell me why should a centrifugal pump be started with the discharge side shut off? Or the discharge valve is closed when we are starting the centrifugal pump? Why?
And,
Okay. So tell me, how do gear pumps, which are positive displacement pumps, how do they build pressure? And compared to a centrifugal pump, do they have any additional equipment?
the gear pumps build pressure by using the mechanical energy. It is the main key difference between dynamic and positive displacement. Uh, in positive displacement pump, we have in the case of gear pump, we have two types of gear pumps. One is the external and other is the internal gear. We are talking about external gear pumps, right?
Yeah.
In external gear pumps, there are the following parts: the prime moving gear, and the second is the following gear, enclosed in a steel casing, or it could be cast iron casing with the
Okay.
primer on it, and which have the suction and the discharge. In this, the prime mover is driven by an electric motor, which are mounted on the common shaft. And both the gears and the external gear pump rotate in opposite directions of each other.
Okay.
Gear pump generates suction by the following method. Like in this gear pump, we have to precisely machine gears so as to maintain the minimal clearance between them. So as to there is no bypassing between the discharge suction and the discharge side.
Okay.
And this helps us to create pressure difference as we have a sealing, proper sealing between both the sides. And when the gears started rotating, they they drawing fluid in their tooth cavity, and then with the rotation, the fluid is trapped between the tooth of the gears and the periphery of the casing,
Mm.
and hence it compresses the fluid. And when it reaches at the top towards the discharge side, this high pressure liquid is uh, uh, is free to move and thus is passed on to the discharge side. And
Okay.
the major advantage of the gear pumps are that they are steady, they are cheap, they are small enough to fit in various places, and fourth is they give a constant supply and can also handle high viscosity fluids.
Okay. So in the middle of the gear pump, the two gears are meshing. There, do we have the
Yeah.
water coming this side or this side? In the middle where the teeth are meshing, water will go from inlet side to outlet side or outlet side to inlet side?
Some fluid will escape from the inlet to the outlet
Okay.
due to the pressure difference.
Okay. And what about the any other components that are fitted on the positive displacement pump?
No, I don't have any.
Okay.
It could be it could be their auxiliary safety settings,
No, no.
safety devices,
Such as?
such as like the lubrication alarm for low
No,
lubrication
no, 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 no.
or
Okay.
pressure
You'll have to
sensors.
study on that. So tell me, what is cavitation?
Cavitation is a process uh, in which there is formation of cavities inside the inside the pipe of the suction side of this pump. Maybe if we call it the centrifugal pump, and it
Okay.
happens due to the negative NPSH, which is net positive suction head. In this, it is the difference between the suction pressure minus the vapor pressure. And
Okay.
cavitation occurs when the vapor pressure is greater than the suction pressure,
Okay.
which boils the liquid as the suction pressure drops. So the liquid starts boiling and forms bubbles, and these bubbles collide with the walls of the pump and burst. And with if this process continues, there are cavities formed within the walls of the pump due to the bubble explosion,
Okay.
and it thus reduces the efficiency of our pump and also the life.
Okay. So you mentioned something about NPSH value. So there are two values, NPSH X and Y. Which are the two values and how are they related? When will cavitation take place? When will they not take place?
That I have no idea.
Okay. So tell me the different boiler mountings and their purpose for that.
The different volume mountings are first is the water level indicator, second the pressure gauges, third is the physical plug, blow off pump, EDS sensors, steam stop valve, feed water stop valve, and the others are economizer, air preheater, and superheater.
You have to also tell what each one is used for. Why this one will be used, when this one will be used. Use of each one as well.
Yeah, water level indicators are mounted on either side of the boiler in the on the side plates of the boiler on both the sides. And
Okay.
the pressure relief valves are mounted on the crown plate, which help us to relieve the pressure if the pressure is more. They are mainly of golden type. Pressure gauges, yeah. They are of, they are for measuring the pressure. Golden type pressure gauges. The pressure relief valves are made up of spring systems. When there is excess pressure inside the boiler, it can be removed. And the fourth is the pre-fusible plug. Fusible plug is also mounted on the crown plate of the boiler, and it is made up of a physical material enclosed in the brass or zinc, uh, brass or zinc body. And it works as follows: that if the water level goes down up to a preset limit for which we are using the physical plug, when the fusible material comes in contact with the steam of the water, it melts away and thus makes a path for the steam to go directly to the firebox. And other one is the blow-off cork. Blow-off cork is mounted on the down plate of the boiler, which is the floor, and it is there for mainly for maintenance purposes or slag removal, dust removal, any other operations. Uh, and then we have the steam stop valve. We use the steam stop valve in order to stop the steam from entering the boiler. If the operator thinks that there can be overload of steam inside the boiler, then there is feed water stop valve in order to stop the feed water from coming into the boiler. It is also a safety mechanism in the boiler. And then we have the superheater. The first is the economizer.
No, so those will not come in the safety part.
Okay.
Those will not come under boiler mountings. Okay, so tell me, what is steam hammering?
Steam hammering. Steam hammering happens when the steam is rushing through the steam pipe outside the boiler, and we suddenly shut off the steam stopper, which suddenly stops the steam, and the steam exerts some pressure on the walls of the relief valve, and thus making a hammer-like sound.
Okay, what is bursting disk? How does it work or help us?
The steam disk is mounted on the crown plate of the boiler, and
So
it is
hint is it has
mounted.
nothing to do with boiler. This is now we are going into main air compressor.
Yeah, the steam disk like study the steam disk
Okay.
exactly. I know its mechanism that it does if there is a more pressure difference between the surroundings and inside of the air compressor.
Yeah,
But
not based on surroundings. This is on the walls of the intercooler and aftercooler. So in case of your pipes in the middle which are carrying water, they burst. Or not
yeah,
carrying water. The
we
pipes
have
will be carrying air. So if they burst, water inside the enclosure of your intercooler will get pressurized. So it might blow off the whole body of the air compressor. So that's where we have the bursting disk. Uh, okay. So next, tell me some non-destructive testing methods.
good. Uh, the non-destructive, there are the there are the following non-destructive techniques. This will be ultrasonic. ultrasonic testing. Second is the dye penetration testing. Third is the magnetic particle testing. Fourth is radiographic testing. And that's all, mainly. And should I explain also?
Sure.
First, let me start with the ultrasonic testing, which is my favorite, because we can use it on a wide variety of materials, be it ceramic, be it non-metallic, be it metallic, be it ferrous. And it works on the principle of reflection of sound within the object when the medium changes. And it has the volume working parts, the probe, the transducer, the into digital display. We and its working is as follows. We put the probe on the work object that we have to scan or detect any faults there are. This probe produces ultrasonic sound, which goes directly into the travels into the work subject. And if there is any crack or hole shut within work object, the sound will bounce back to the surface again from there.
Okay.
This return mechanical wave is absorbed by the probe, and in the probe itself is the transducer. The transducer helps in converting the mechanical signal into the electric signal for the digital display. And on the digital display, we get the ECG-like readings where it is mentioned the depth and the delay in sound and the speed of the sound, etc., which help us in configuring that what is the orientation, the size, and the location of the fault within the web subject. And the second one is magnetic particle testing. Its working principle is mainly the leakage in the magnetic flux. And we need we need the following things for the cooperate. First is the magnetic ferrous dust or iron dust, I would say. The second is the electromagnet from which we will generate the magnetic flux. Now the working is as follows. We sprinkle the ferrous dust on the surface of the work subject, and when we when we take the electromagnet near the work subject, if there are any cracks or cold sets on the surface of the ferrous material, the iron ferrous dust will gather around that disorientation due to the leakage in magnetic flux, and thus highlighting the fault in the work subject. Now, mainly the disadvantage of this magnetic particle testing is that firstly it is not that accurate as we think it would be, as it depends on the power of the electromagnet.
Okay.
And second is it can only detect the faults on the surface of the work surface, not inside. And it can be only used for ferrous materials,
Okay.
which is a very small group in the domain. Right. Now coming to the dye penetration testing. In dye penetration testing, we have the dyes and the absorber and any brushes or lacquer we may use.
Okay.
Its working principle is the capillary action of fluid, and its working is as follows. With
Okay, that's fine for that. So explain the three-phase induction motor.
the three-phase induction motor was invented by Nikola Tesla. And it is a very rugged type of motor, and it is the most common motor today we will find in the world. Like we will find there are out of 100 motors, 80 motors will be induction motors. And there are two types of induction motors. One is squirrel cage, and second is iron core, metal wound, induction motor. Now, in the induction motor, we have the following working parts. First is the rotor, this stator, with the windings at 120-degree angle each, uh, and the stiffeners and uh, brushes, carbon brushes, and that's it. We have also a battery to power it. Now, the induction motor works on the principle of Faraday's law of electromagnetism, and second is the Lenz's law. Uh, and thirdly, if I must mention, it uses the left and right. Uh, Now the working is as follows. When we pass the current through the stator winding, uh, I should practice how to speak on the induction motor because I left the part of the rotating magnetic field and the synchronous field. Uh, we create a rotating magnetic field in the stator which has an angle of 150-degree angle between them, and this rotating magnetic field induces electromagnetic current in the rotor based on the Faraday's law of electromagnetic induction.
Okay.
And it also and due to the Lenz law, there is magnetic field generated in it opposite to the direction of the rotating magnetic field, and this makes the rotor also rotate. And this rotation is used for the used by the user for any further application. And yes.
Okay, so what can you tell me regarding the speed of the magnetic field is rotating and the speed of the rotor? Will they be the same?
No, if the speed of both if becomes the same, there will be no magnetic current, magnetic field induced inside the rotor, as there will be no change in flux, as they both will be moving at the same speeds, and thus will our rotor will shut down
So what is
for
this
that
thing called?
synchronous speed.
Synchronous.
Yes.
Okay, it's called asynchronous because they're not at the same speed.
No, if they are rotating with the same speed, it's synchronous. It's
Okay,
synchronous. It's
induction
a
motor.
direct thing. What induction
No, no,
motor?
in the induction motor they're rotating at the same speed.
No, no, they are not rotating in the same speed. They
Okay,
are rotating at different speeds.
okay,
The stator rotating magnetic field is faster
okay,
than the rotor magnetic
okay, fine. So give me a quick rundown on the whole VCRS cycle with diagram.
field. Sure. First, should I draw the
Yeah,
diagram?
sure, draw it, draw it.
Sorry for the background noise. This is for sure. Um, We, we have the four main working parts: the evaporator, then the compressor, the condenser, and the expansion valve.
Okay.
In the VCRS cycle, the VCRS is for vapor compression refrigeration. And I have mentioned the working parts. And should I also mention the phase change in the diagram?
Yeah, tell me what is this pressure and state of the fluid passing through it at all of the positions throughout the cycle.
Yeah. Let us start with the evaporator. The vapor before entering the evaporator is of -8 to -20 degrees Celsius and is in form of low pressure, low temperature vapor plus liquid.
Okay.
And after passing through the evaporator, it becomes 80 to 90 degrees Celsius and low pressure, high temperature vapor.
Okay.
And after passing through the compressor, it becomes high pressure, high temperature vapor. Then after passing through the
After compressor,
condenser,
you said liquid, right? Or
no,
vapor?
no, high pressure, high temperature vapor
Okay, vapor. Okay.
after the compressor. Then after the condenser, we have high pressure, high temperature liquid. And I have mentioned after the expansion valve.
Okay.
And mainly evaporator is situated inside the refrigeration compartment. The compressor is at the bottom of the refrigeration system. The condenser is at the backside or the outside of the refrigeration system. Like in home, we see flat tubes running in the backside of the refrigerator. And yes,
Okay. What's the use of the
there are
sensing
some.
bulb?
Yeah.
Sensing bulb.
I have to study that. It is after the condenser, before the evaporator.
No, it is near the evaporator.
Okay. I will study it.
Okay, fine. What are some tools used on board?
Workshop tools, right?
Yeah.
Uh, we use the following tools. First, let me begin by strapping tools like hammers and like hammers. There are different types of hammers used, ball peen hammer, and etc. Second are the cutting tools we could use that are hacksaws or even drills to be precise. And the other tools are mainly the Allen keys that we use to tie it or loosen the nut. And other tools are mainly for the checking of the quality of installation, like voltage, vernier caliper, and feeler gauge, and plunger dial, etc.
Okay. So, what is tappet clearance?
Rapid clearance is the clearance between the locker arm and the head of the valve cap.
Why it is required?
It is required as the engine operates at high temperatures, right? So, due to the high temperature, the can could get enlarged, and thus there is a clearance required. Because if the can gets enlarged and we do not have a clearance, the can will remain pushed down throughout the whole cycle.
Okay.
That will create malfunction scenario. I see in the system.
Which one has more? Inlet valve has more, or exhaust valve has more tappet clearance?
Most problems not
Okay.
rapid clearance.
And what tool is used, or which type of instrument is used to set it up correctly?
Okay.
Okay, fine. So that's the end of the thing.
Okay.
Yeah, I'll send you the list of all of the feedback and all of that, and then you can start working on them separately.
Sir, let me mention one thing, Avito. Like I prepared all these topics like I, to be precise, not all these topics. Some questions were new for me.
Hmm.
I must thank you for that.
Yeah.
But mainly the ignition cycle, all I had learned about that, but I was not able to remember that properly. I studied today, but I was not able to study the whole notes I had
Hmm.
prepared.
Yeah.
So it
Also,
was
like
kind
you'll
of
have to
confusing.
start framing the questions. Like directly. Like you, when you say induction motor, you can't deviate into like they'll be used by in large numbers like 180. So directly you have to go to the topic because otherwise it looks like you're rotating around like.
Okay.
So that's that. Apart from that, I'll send you the list of this, and I also have recorded this, so you can watch the recording as well to have a look at it.
Yeah, thank
Yeah, bye.
you.